Hey everyone, here is our 3.1 notes today. We're going to start learning about different types of interactions between lines and different types of angle relationships. So on this first page in the student journal, there are some vocab words, and I'm only going to go over one of them because the following pages have these and we'll discuss them. So we're going to learn about parallel lines today, skew lines, parallel planes, but the first thing is what's called a transversal. So if we look here where it says transversal, a transversal is a line that intersects two or more coplanar lines at different points. So for example, I could have two lines here, right? Here's two lines, and then my transversal is going to be this red one here. So remember, a transversal is a line that intersects two or more lines that are in the same plane, coplanar, at different points. So this red line is my transversal here. Now, when we have two lines being cut by a transversal, then it is going to create the following angles. We have things called corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. And I will go over those as we get further in the lesson. So the first thing we have to get to is this idea of what are parallel lines, skew lines, and parallel planes. So I'm going to read this. Two lines that do not intersect are either parallel lines or skew lines. Two lines are parallel when they do not intersect and are coplanar. So I'm going to highlight that real quick here. Parallel lines are when they do not intersect but are coplanar. And two lines are skew lines when they do not intersect and are not coplanar. So I'm going to do a little example here. I'm going to zoom out a little bit. I'm going to draw a cube the best that I can. So just not all the sides of a cube. So this is really bad drawing. So here's a little bit of a like a rectangular prism here. So parallel lines could be, for example, this red line here and this red line here are going to be parallel. It's also parallel to this. Now, all three of those are considered parallel to each other, even though the one that I'm pointing to with my red arrow here looks like it's on a different plane. We could actually draw a plane that connects these two right here, green. So now I have this green plane that actually shows that those other two lines are still parallel. We just don't always draw that plane. Now I'm going to redraw this little prism and discuss again parallel lines along with skew lines. Let me start my prism here. So for example, if I want to talk about parallel lines, I could have, again, these red ones here. These are going to be parallel to each other. Let's say we talk about a skew line. So a skew line, I'm going to change the colors up here. I could have this vertical line here in blue, and then I could have this, either one of these lines here that are in blue. So this one and either of the other ones, those are considered skew because they're not on the same plane and they don't intersect. So notice skew lines do not look parallel. They don't intersect, but they're also not parallel. If lines look like they're parallel, even though it looks like they're on different planes, there's a good chance that you can actually draw a plane that contains both of them. So skew line is probably the most commonly missed question on a quiz with these different types. Now they do give us an example over here on the left in the gray picture that shows lines M and N are parallel. Now this is called the parallel symbol right here. I'm going to show you this symbol. Two vertical lines, this is the parallel symbol when you're writing it. Just like we had perpendicular, was like an upside down capital T. So that's how we say lines M and N are parallel to each other. Also notice these little arrows here. The arrows on a line in the middle show parallel. So for example, if I want to say that my lines are parallel, so I'm going to draw two pairs of parallel lines here. I would put little arrows on here. Let me erase that, sorry. That shows parallel. And let's say in the same diagram, I have another two lines that are parallel. Then I could put two arrows, meaning that those two are parallel, even though they're the same picture. So the number of arrows on a line, if you match it with the number of arrows on a number line, mean those are parallel to each other. Now, in this diagram on the left, the skew line would be this vertical line that goes between planes U and T, and it would be skew with line M because it doesn't touch that line. Just so happens it does intersect line N, so it's not skew with line N, just lines M. Now, planes that do not intersect are parallel planes, but I think that's pretty self-explanatory. All right. Now we got parallel, skew, and parallel planes down. Let's look at our first postulate here. Our first postulate says if there is a line and a point not on that line, then there is exactly one line that can go through that point that is parallel to the line. So what that means is, let's say we're given line L. So here's line L, and we have point P. There is exactly one line that we can draw through point P that becomes parallel with line L. That's the parallel postulate. Okay, let's go to the next one. Now we have perpendicular postulate. Same thing. If we have a line and we have a point not on that line, there is exactly one line that goes through that point that is now perpendicular to the original line. And just a little reminder, when we say perpendicular, let's say we had lines M and N, we'd say like M is perpendicular to N. That's how we would write perpendicular. Now, in this example, P is a point. It is not a line, so you have to be very careful not to say P is perpendicular to L. Okay. So those are the parallel, perpendicular, skew information that we know. Now, this is where you might want to pause the video here in a second and look at the angles formed by the transversal. These are our special angles relationships. And when we get to parallel lines, they will have special properties. There are four that we need to know. And we can't forget that we've already learned about vertical lines and linear pairs. So there's really a total of six that you are required to know. The first one is corresponding. Corresponding, this is when we have a transversal that cuts two lines. If they're in the same relative position, corresponding position, they are called corresponding. When I mean same relative position, notice I have four quadrants in this top intersection and four quadrants in this bottom intersection. Angle 2 is on my top right. Angle 6 is on the top right. Since they're in the same relative location in their intersections, they are considered corresponding angles. Then we can look at what's called alternate interior angles. So interior means in the inside of our two lines. Okay, so all this inside that I'm circling here with this red arrow. And then alternating means opposite sides. Now notice 5 is down here by this bottom line. Angle 4 is by this upper line. And they have to be on opposite sides, but also opposite corners. The reason why, I'll put my little arrow right here. If angle 4 was a next door neighbor to angle 5, it would not be an alternate interior angle. It would be a linear pair. And then we can have alternate exterior angles, which means they're on the exterior of the two lines that are cut by the transversal, but on alternating sides. Okay, so angle 1 and 8 are on alternating sides of the exterior. And then we have consecutive interior angles, and some teachers in some different textbooks will also call this a same side interior angle. Before we move on, I just want to remind you, I'm going to do the same thing here. I'm going to have two lines cut by a transversal. And I want to point out if we call this one angle 1 and this angle 2, I would say angle 1 and angle 2 are a linear pair where angle 1 and angle 3 are vertical angles. So we can't forget linear pair and vertical angles. All right, let's go to the next page. So some extra practice problems here. I might not go through every single one because some of these have multiple answers. I might just do a couple. But we just have to start practicing identifying what things are skew, perpendicular, parallel, all that good stuff. So in these first four, we want to think of each segment in the diagram as part of a line. We just cut off the ends of the line, so now we can make this trapezoidal prism. I almost forgot the word there. So this is a trapezoidal prism, and each of these segments are part of a line, and it does ask which lines or planes contain point B and appear to fit the description. So we're focusing on point B, which I'm going to make nice and obvious here. So let's look at this first one. It says that we want to find a line skew to FG. So FG is this line right here on the top. And so I want a line that is not parallel, does not intersect, but not on the same plane. So lines that would be parallel to FG would be like EH, AB, DC. But if I want point B and a line that is each of these segments that is drawn here, let's look at BC. And I'm going to eventually erase this, but BC would be this line right here. It's in the front side of this. So the line BC would be skew to FG. Now, that's not the only one. That's the only one that's drawn. Now, if I don't want to talk about drawn lines, eventually there do exist lines like DB or BH or EB. There's a lot of them, but let's just focus on the ones that are drawn right now. The ones that are drawn, it would just be line BC. Lines perpendicular to FG that go through B. Now, perpendicular means you're looking for that little perpendicular symbol. So I want to find lines that are perpendicular to FG. I see a perpendicular symbol here, but this is the line AF, which does not contain B. And then I see a perpendicular symbol here at point G on line FG, and it goes through B, so that'd be line BG. So I'm gonna put B. G, don't put your line symbol on top. And then lines that are parallel to FG that go through B would just be lines A, B. Just line A, B right here. Remember, everything has to contain point B with our answer. Now, planes parallel. Parallel to plane FGH. That plane is the backside plane here. So a plane parallel with that is going to be the plane here on the front side, which is A, B, C, and D are the points, and I can pick any three long as they're non-coplanar. So I might just call that plane. Put the word plane here. A, B, C. You could do A, B, D, any 3 points, but preferably use the point B since it'll make more sense when we want our answers to have something that contains point B. Next section, name a pair of parallel lines. We're going to look at the different symbols. So I'm going to highlight here. It doesn't really matter. I'm going to look at parallel line symbols. I see the two line marks. So these yellow lines are parallel to each other. I also see the single mark. So these lines that are more like in the purplish blue are also parallel. So it says name a pair. We have a couple options. We could say like lines WX. So we could say WX are parallel, well, sorry, is parallel to YZ, so line YZ. That's one option. You could have said UV is parallel to QR. You could even use the point N in some of these because point N is in WX. It's also in UV. So you have some other ways to name some of these lines, but these are the most simple ways. Name a pair of perpendicular lines. So I'm going to erase what I have right here, and let's just focus on the the perpendicular symbols. I only see one perpendicular symbol, so we can't assume anything else is perpendicular. My perpendicular symbol shows these two lines right here because of this symbol. There's no other lines right now. We haven't learned about other theorems that would say, hey, well, shouldn't QR be perpendicular to ST if UV is perpendicular? We haven't learned about that. So the only one that we can say for sure, based on the diagram, is ST. I keep on trying to draw on the highlighter version. ST, that line is perpendicular. I'm going to use the symbol here to line UV. Then it says, is WX, I'm going to do some erasing here. I like to trace these. It helps me understand what's going on. Is WX parallel to QR? So let's look here. WX, this bluish line, is it parallel to QR? And that answer would be no. And if it says explain why, you can say that they do, no, they do not have matching parallel symbols or marks. Symbols, I guess they're technically maybe marks. Now, is ST perpendicular to NV? So I'm going to erase this and see what happens. ST to NV. So N to V is this one right here. And this would be yes. And why? We see a perpendicular mark. That's this mark right here. All right, angle relationships. It says identify all the pairs. I'm not going to do all of them. I'm just going to do a couple. So corresponding. Let's talk about angles in the same location. So what if we talk about like angle one here? Angle one, and angle one is on the bottom left. So is angle five. I would call that like a bottom left, and so is angle 9 on a bottom left. Okay, so I can say angle 1 and angle 5. I can also say angle 1 and angle 9. Now, there's a lot if we listed all of them. Let's just practice one more. What if I focused on angle 7? So angle 7, I'm going to highlight here. Angle 7's on the bottom. Now, when I say bottom, angle 3 is on the bottom. But look at 10, 12, 11, and 9. It's not quite the same in the spot, but if you were able to ignore this section right here, I can see now that with my transversal, with the two lines here, if I look at my two lines with the transversal, and here's my transversal, and the two lines are the green right here and this green right here, my corresponding angle here is going to be angle 9. So this is 7 and angle 9. And we also know that we have angle 7 and angle 3. But I'm going to quickly highlight the next one just because it might be helpful to see how it's angle 3. You sort of just have to slow down a little bit. Here's my transversal, and then I have this red one here. If I look, I can now see that 7 and 3 are in the same spot. It's a little bit easier to see now because now I have like a top left, a top right, top left, top right, and I have a bottom left and bottom right. So angle 7 and angle 3 are corresponding. Then we have, let's go down to alternate interior. Alternate interior, again, this is a little hard because we have three, we have we have quite a few lines here that intersect each other. But if we focus on just one part at a time, so let's say we just cross off this section here. If I cross off this section for alternate interior, I can see that 2 and 7 are alternate interior, so angle 2 and angle 7. And that also means 4 and 5. So angle 4 and angle 5 are alternate interior. Now, if I was to erase that and hide a different intersection, so what if I was to hide part right here? So we're going to hide these. Our alternate interiors would be 7 and 12, and then we'd have 10 and 8. So there's some alternate interiors. Again, I'm not writing them all. I just want to point out some. Then we get to alternate exterior. Again, we might want to cross off one of these sections. So let's say I cross off this top section here. Let's just focus on, we have two lines cut by a transversal. My transversal is this red line here. My alternate exterior angles would be like angles 1 and 12. So angle 1 and angle 12 are alternate exterior. And then that'll also be, we have angles 2 and 11. So angle 2 and angle 11. And then we can, again, maybe focus on a different pair. So let's focus on, let's say the one here, these two on the left. So let's get rid of this one, cover it up with a piece of paper maybe. I can see my alternate exterior angles are 3 and 6. And then I can also see angles 1 and 8. So that would be your alternate exterior. And then last but not least, sorry, I know this is a long lesson, is we have our consecutive interior angles, also known as same side interior. So let's just get rid of let's cover up this top one. If I covered up this top one, my interior angles are going to be 4, 10, 3, and 9. Well, 4 and 9 are alternate. Angle 4 and angle 9, sorry, wait, I said alternate. We are talking about consecutive interior. My bad. Let's consecutive interior mean they're going to be on the same side. So consecutive means next door or side by side. So that would be 4 and 10. My bad. Angle 4 and angle 10. And then we also have angles 3 and 9. Angle 3 and angle 9. I'm going to do one more pair that I talk about. I'm not going to write them down, but let's maybe hide this section here. And so my, sorry, excuse me, as I'm coughing, my same side interior could be 7 and 10, and then angles 8 and 12, or also known as your consecutive interior. All right, sorry that's such a long lesson, but it's a really important one. We have lots of theorems that involve these going forward, a lot. This whole unit is based on these angle relationships. So make sure you know these really well, really, 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 really well. All right. All right. We'll see you in the next lesson or in class. I hope you have a wonderful day.